let's start by looking at the acetal hydrolysis. And in this case, I'm using a cyclic acetal. So in terms of just predicting the products, what you can do is identify the acetal carbon. That's the carbon where the two oxygens are attached. And that's where the bonds are going to end up breaking. Okay, and to draw the product, all I'm going to do is take that carbon where I put the blue highlight. That ends up becoming the carbonyl. So we'll put a double bond O there. And then the two bonds to the oxygens that I broke, those will end up becoming OHs. So there's the hydrolysis products. Right, now let's look at the mechanism for this. I'm going to start with my acetal. And the first thing that will happen is the acid will add to one of the oxygens. Okay, and if you were to look back at the acetal formation mechanism, this would be the last intermediate before you get to the product. Okay, the next thing that's going to happen is we're going to break that carbon-oxygen bond. I'm going to use a lone pair on the neighboring oxygen to assist me. And when we do so, we get this intermediate. Next, we're going to involve the water. So we've added a bunch of water to do this hydrolysis, so it's ready and available to add. I'm going to add it to this activated carbonyl. So I want to put the water over here on the left. And then our oxygen on the right. Right, now we need to do the proton transfer. And you can do this in 2 steps or 1 step. So if you do 2 steps, which is what I'll go ahead and do, we'll use a base and take the proton off of this oxygen. And then in the second step, we'll protonate the other oxygen using that same proton. Now, if you had wanted, it would be totally acceptable, in my opinion, to just use a lone pair on this oxygen, grab a proton, and just directly go to this protonated form. That's a shortcut for the proton transfer. Next step is we're going to lose that alcohol group. And I'll use a lone pair on this oxygen, push that down, and that will break the bond to this leaving group. So that ends up giving me just a protonated carbonyl. Plus, this is where the diol comes out. Finally, you can just use a weak base B to take the final proton off. And now we're left with a ketone.